This is video is on about Leetcode 637 averaging on levels in a binary tree. So this problem we tackle with breadth first search. If you look into the solution, it's breadth first search, and I want to add value to this particular question. And this video will not cover, if you're looking for solutions, probably won't be the best place, but I really want to give some of my insights on this problem that I find really helpful using to kind of really understand breadth research at a very deeper level, or to a level that I understand. So, breadth research, it's a level order traversal, right? You kind of go, well, okay, you got this tree, and you're kind of um, doing a level order. That means going level by level, three, not, and then you're using Q. If you look around internet for breadth first search, you're using Q and Q like this, right? So three, go by level, 3, 9, 20, 15, 7. And that's really how it's happening in the queue. If you don't DQ the queue, DQ item from the queue, DQ items from the queue, 3, 9, 20, 15, 7, right? But I do kind of find like visualizing this queue a bit difficult. Um, for some reason, I find, yeah, because there's time dimension missing in this picture, because as you're kind of iterating through the uh, item, the state of the queue changes per time or per iteration, right? So you just need to keep track of these queue, and it's just, for me, it takes extra brain cycles. So what has really helped me is to kind of view this queue as a two-dimensional queue, or a two-dimensional matrix. um, a matrix is usually a list at a list, but in this case you can kind of consider um, this single dimensional queue. Just visualize it as a 2D matrix, or a 2D, a 1D queue, but that looks like a 2D. Like, just transform it to look like a 2D matrix. And I feel like if once you do that, the problem really becomes really trivial, and the code implementation really aligns really perfectly with the the image or the depiction. So if you remember, if you have a 2D matrix, you you can iterate through all the cells in the matrix by just running a nested for loop, right? So in similarly, like over here, you can really do a nested for loop, which, I mean, if you look at the implementation of breadth first search, there is a nesting component towards there, where there is a while loop, and there's a for loop inside that while loop, and that structure of the code really like aligns really well with this particular visualization. And for me, it really helps to really like understand depth first search at a bigger level. um and reason about, because I really feel like I have intuitive understanding of this 2D matrices better than a single queue, a one dimensional queue, where you just like add stuff, remove stuff, because I just don't use queues in daily life that much. There's not many queues. Yeah, I just don't see it, but I see matrices a lot. I deal with them a lot from my deep learning background. So yeah, I mean, let's look at the implementation itself. Whoops, where am I? Yeah, so let's look at the implementation itself right here. Um, and you'll see what I mean. So uh, if not root, let me, where is this? This is a tab indentation, correct? Yep. If not root, return. This is literally just the base case, right? If root is none, then you kind of just return an empty array that nothing levels here. And what has really helped me is like, if instead of creating a queue, like naming the variable queue, you just for name it levels, or and just initialize that to a root, right? Um, and while levels, right? Um, for oh my god, range level length. Level length is len of levels, right? And here's what I mean by the code really aligns perfectly with the the structure that we kind of, or at least I'm visualizing in my head. So if you see, there's a nested thing going on, which suggests to me there's some kind of two-dimensional thing or 2D thing going on, 2D structure that really plays out well. Um, so if you look at this, while levels and for I in range level length, it just kind of, it blends really well with us iterating through these, just like we iterate through a matrix, we're iterating through this grid, which happens to be a queue, right? um, and the base case, the outer loop, is levels is when levels contain some element, right? So it's kind of like saying, hey, if the structure contains some element, then we want to we want to run the while loop. So yeah, I mean, that makes perfect sense. And the inner for loop is just kind of iterating through a particular row, columns of it. So we're just kind of like, um, just like how we would do in when we're iterating through a matrix. Um, yeah, so that's the biggest insight, really. I think once we kind of think in that mentality, we can kind of really like appreciate um, how this implementation really gives us access to level level properties, right? For example, level length, we can really have access to how many nodes. We can keep track of how many nodes are there in a particular level and stuff like that, or even do some very level related stuff, right? Or row related stuff. Row, if I'm talking about that particular structure. So uh, in this case, level sum would be 0, and right, and here we're just really filling in the next level out. If node uh, yeah, if node uh, uh, append node dot left. Okay. Left with right. Okay. And then, so yeah, over here we're just kind of filling the next level. So that's in my mind, or the structure. That's what's happening over here. Um, the level, when you're dealing with a level or an appending stuff to it, when you're appending stuff to the levels, you're actually appending it to the next row. That's how you can visualize it, at least, and things becomes much easier to handle in our brain and to conceptualize this. So um what's going on? Yeah, and then we gotta add the level sum. So root, I think it is a node dot val, but we kind of need to pop out the node. uh, levels dot pop, right? Node. I mean, it's this editor is quite bad because there's no IntelliSense, but you get the point. And once we're done with the level, so once we're kind of done with the row, processing the row, all we gotta do is like uh, res. I mean, there's no res, so let's create a res result array. Um, Pend level sum over divided by level length, and just return res. I think this answer you can easily find. I feel like the main key insight from on this video I like to deliver or at least give you is the fact that yeah, it runs. Hopefully, it runs well as well. Submission looks great. Okay, so it's a pretty average solution, but I feel like the most important key insight is just this particular structure. Have instead of looking at it as a queue, single one-dimensional queue, look at it as treat it in your mind as a two-dimensional entity, and you're just kind of iterating over that two-dimensional entity. And this just makes breadth first search a whole lot easier to conceptualize and visualize. All right, thanks.